Let me tell you a harsh truth. The sun has only 22 revolutions left around the Milky Way before its light dies forever. Earth will vanish, and humankind will cease to exist. This may sound distant and unimaginable because it far exceeds the scale of human civilization and even our concept of time itself. But on the scale of the universe, this is only a fleeting moment. Scientists estimate that the total lifespan of the sun is about 10 billion years, and it has already been burning for 4.6 billion years. It is currently in its main sequence stage, steadily releasing light and heat, but this stability is only temporary. Over the next billion years, the sun's brightness will gradually increase, causing the Earth's temperature to rise as well. The oceans will be evaporated by the scorching sunlight, the greenhouse effect will spiral out of control, and the water cycle system will eventually collapse. When the concentration of carbon dioxide in the atmosphere drops to a level insufficient to sustain photosynthesis, plants will wither in vast numbers, the foundation of the ecosystem will be shaken, and the food chain will collapse completely. In the end, this once blue planet that nurtured countless forms of life will no longer be suitable for any form of existence. Therefore, the real countdown is not 5 billion years, but 1 billion. What will happen to Earth after the sun dies? In 5 billion years, when the sun's core exhausts its hydrogen fuel, it will enter the red giant phase, expanding to several hundred times its current size. Mercury and Venus will be swallowed, and the Earth will be surrounded by searing plasma, with surface temperatures high enough to melt rock. When the sun sheds its outer layers, it will leave behind a dense core, a white dwarf, which will gradually cool and fade away, eventually disappearing into the darkness of the universe. As for the Earth, it will either be consumed during the sun's expansion or, even if it somehow escapes, will be scorched into a barren wasteland, completely stripped of its atmosphere and water, becoming a dead and silent planet. In either case, Earth will meet its end. Before that happens, can we migrate to other habitable planets in the solar system? In the search for a second Earth, Mars is currently the most promising candidate. It lies on the outer edge of the sun's habitable zone and has alternating days and nights, polar ice caps, and seasonal climate variations. Although Mars has a thin atmosphere and extremely low temperatures, scientists believe that by releasing greenhouse gases, introducing microorganisms, and establishing an artificial magnetic field, it might one day be transformed into a planet suitable for human habitation. Another good option is Jupiter's moon Europa. Europa is covered by a thick layer of ice, beneath which may lie a liquid ocean that provides the basic conditions for life to exist. Although its surface temperature is extremely low, future humans might build enclosed underground bases that rely on geothermal energy or other systems to sustain ecological cycles. There is also Titan, Saturn's largest moon. It has the second thickest atmosphere in the solar system after Earth, dominated by nitrogen, and features a surface with liquid methane cycles that can replace water cycles, forming lakes, rivers, and even weather patterns. Moreover, Saturn's magnetic field and Titan's thick atmosphere can block most solar and cosmic radiation. The key issue, however, is that all of these worlds share a common problem. None of them can escape the sun's evolutionary fate. Even if humans manage to establish colonies on Mars, Europa, or Titan, the increasing brightness of the sun in 1 billion years will still make these worlds uninhabitable. The habitable regions within our solar system are merely temporary shelters, not eternal homes. For this reason, scientists have turned their attention to more distant exoplanets. Over the past 20 years, with the help of the Kepler telescope, the TESS mission, and ground-based observatories, humans have discovered more than 5,000 exoplanets, dozens of which are located within their stars' habitable zones and may have liquid water, such as Proxima Centauri b, located only 4.2 light-years from Earth. It is the closest known exoplanet to the Sun, orbiting the red dwarf star Proxima Centauri. Although it lies within the habitable zone, Proxima's strong stellar winds and flares may make its surface environment extremely harsh. About 40 light-years away lies the TRAPPIST-1 system, often called a second solar system, which is known to host 7 rocky planets. 4 of them are within the habitable zone. Planets E, F, and G are especially notable. Among them, Planet E and Planet F are most similar to Earth. Planet E is located in the middle of the habitable zone, with a mass about 1.03 times that of Earth. The latest observations from the James Webb Space Telescope suggest that Planet E may have an atmosphere dominated by nitrogen and likely possesses liquid water. Scientists estimate a high probability that its surface hosts oceans, making it the most promising candidate for an Earth-like world. Planet F, with a mass about 1.04 times that of Earth and similar in size, also lies in the central habitable zone. Studies have found methane fluctuations at its poles and possible deposits of liquid water and ice, earning it the nickname Earth's twin sister. About 600 light-years away lies Kepler 22b, with a diameter about 2.4 times that of Earth. It orbits a sun-like star, with a surface temperature of around 21 degrees Celsius, making it one of the most Earth-like planets discovered so far. But the problem remains. How can we get there? The farthest human-made object, Voyager 1, has been traveling for 48 years at a speed of 17 kilometers per second and has covered 24.9 billion kilometers. At that speed, reaching Proxima Centauri would take 73,000 years, and reaching the TRAPPIST-1 system, 40 light-years away, would take nearly 700,000 years, far beyond the lifespan of human civilization or the stability of any social structure. To address this, scientists have proposed various ideas to increase spacecraft speed and reduce travel time. One concept is the Generation Ship, a self-sustaining space ark where humans would live and reproduce for generations until finally reaching their destination. Other proposed technologies include controlled nuclear fusion propulsion, light sail propulsion, and antimatter engines. These high-energy propulsion methods could potentially reduce travel time to a few centuries or even decades. Research on these technologies is steadily advancing because humanity does not have much time left. Therefore, we must face the reality that the sun will eventually die, and Earth is not humanity's eternal home. Migration is not science fiction. It is an inevitable destiny our civilization will have to confront. One thing is certain. If we merely stay on Earth and wait for the end, we will have no choice at all. The extinction of the sun is the universe's destined fate, but whether humanity can leave its mark in the depths of the cosmos depends entirely on the choices we make today. The stars and the sea are not just distant dreams. They are the path of survival we must one day take.